Hello again from Digicool Things. First off, you can probably see that I have my MECB based CreatiVision recreation at the top left of my workbench. In previous videos, I showed the video output by simply pointing my video camera at the monitor. This, unfortunately, always created issues with reflections from my windows, as well as image focus challenges. So, I've finally got myself another video capture card to allow me to instead directly capture the VDP display card output. And here's what it looks like. It's pretty awesome and a significant improvement on my camera recorded video screens of the past. But even more so, it looks more reflective of what I actually see on the monitor in terms of colour and sharpness. So, back to the main topic of this video, which you'll also see why having my CreatiVision recreation handy is relevant. Last year, I created a PLCC package-based 6309 CPU card. The CPU card made use of the PCB space saved by using the PLCC package CPU to also include PLCC packaged 1MB ROM expansion. This effectively made the 6309 PLCC CPU card a combination of the existing dual-inline packaged-based 6809 card and the 1MB ROM expansion card. Not only did the PLCC CPU card deliver 2-in-1 functionality, it also looked awesome with its through-hole socketed PLCC chips. The whole card still remaining through-hole retro-friendly for easy assembly. So, I've now done the same thing for the existing MECB 6502 CPU card. I've taken the existing dual-inline package 6502 CPU card and made a 2-in-1 combination 6502 CPU and ROM expansion PLCC based card. Doing this makes a really nice 6502 CPU card. It also benefits my CreatiVision recreation project, as this combination card means there's now one less card required for a full 16-game CreatiVision recreation. Now, there's one important thing to note. The pinout of the original 6502 PLCC package CPU chips differs from WDC's W65C02 PLCC pinout. So I had to choose one or the other. Since the WDC 65C02 is still in production and therefore easy to source brand new in its PLCC package, and it's also capable of higher clock speeds, I decided that for the PLCC version 6502 CPU card, I'd go with WDC. So here is the schematic. It shares the same improvements that I implemented in the 6309 PLCC card. Be sure to watch the 6309 PLCC CPU card presentation for full details of the improvements. In addition, the 6502 card also has the addition of the debounced manual NMI switch and header that the existing 6502 dual-inline package CPU card has. Here's the 3D render of the resulting PCB. Now, on my workbench, you can see I've laid out the PCB and all of the optional component packs. Also, I've laid out the additional required components, all ready for my first card assembly and testing. But first, for this new CPU card, I've decided to do a couple of extra things with my Tindie Store listing, in the interest of making your parts procurement as easy and convenient as possible. Firstly, I've expanded the optional pack offerings to make the parts that are available from me more complete. In this way, you have the convenience of ordering most of the parts together with your PCB. Secondly, I've made sure that the additional components required can all be ordered from a single source. To this end, the bill of materials provides all of the part numbers for ordering these additional required parts from Mouser. Alternatively, these relatively common parts are perhaps also available from your own preferred supplier, or they may even be in your existing part storage. If this added convenience is helpful, I'll also look at doing the same for my other MECB card offerings on Tindie. So, with that update explained, I'll now dive into getting this new CPU card assembled. I'll start with the dual inline IC sockets. Noting that the first thing I need to do is push out the 4 centre pins on one of the 8-pin sockets for the crystal oscillator, and this is what it looks like. Okay, let's get them soldered. Next I'll do the capacitors and the resistor networks. Next I'll do the dual inline switch. Now I'll do the headers. So now I'll do the PLCC sockets. Right, now I'll do the remaining switches. Finally, we have the DIN connector. Let's get that done. And here is the fully soldered card. So, next we'll install the ROM read-only jumper. Then we'll insert all of the dual inline chips, with the exception of the Glue Logic PLD. So let's insert the RAM. Then the inverter. Then we've got the 8-bit comparator. Then we've got the debounced reset. And the optional debounced NMI. And we'll put in the crystal. Also, we'll insert the WDC W65C02S PLCC package CPU. Now, pin 1 is over here. Now, the simplest way to test the new CPU card is with my existing CreatiVision recreation, which, as you saw earlier, I currently have running on my workbench. So I'll replace both the existing 6502 CPU card and the 1MB ROM Expansion Card with this new 2-in-1 replacement card. For this use, I won't use the default 48K 16K memory map PLD. So for this, I'll load a new PLD with an appropriate CreatiVision memory map configuration. So I'll configure with 4K of RAM at the bottom of memory from 0000 to 0FFF and 48K of ROM for each 64K bank in the top of memory from 4000 to FFFF. Note also that the address range in between 1000 to 3FFF is used by the CreatiVision for mapping its I/O. So I've got that PLD programmed and I'll insert that now. And I'll put the old PLD aside. Then for the ROMs, I'll program them with the ROM image files that are also used in the current ROM Expansion Card. As usual, you'll find these CreatiVision ROM files and the PLD files available on the Digicool Things MECB GitHub repository. So let's get that done. Right, and here's the two programmed ROMs and labelled, which I'll now get inserted. Firstly, we've got ROM 0, CreatiVision ROM 0, goes in there, and CreatiVision ROM 1. And I think we're ready for our first test. So I'll add a couple of PCB standoffs to our new CPU card so that I can plug it in to the backplane's horizontal connector for initial testing. Okay, so I'll turn off the CreatiVision recreation and I'll remove the two existing cards. The original 6502 CPU card and the 1 MB ROM expansion. I might also just swap across the crystals because I've got a 2 MHz oscillator for the CreatiVision. Now I'll plug in the new card, which combines the CPU and ROM expansion cards. And we should be ready for our first test. Alright, let's power up and see if we have a working CreatiVision recreation. Well, that's disappointing. We have a blank screen, so it looks like it's time for some fault finding. So, I started my fault finding with a close visual inspection of my soldering, also checking part orientation and testing power, pull-ups and connections using my multimeter. After this didn't find any issues, I then fired up my oscilloscope to check that all of the vital signals were present. Everything actually looked good. I had a good clock signal on the CPU, a good reset signal, and plenty of activity on the data and address buses, as well as appropriate control signal activity. So at this point, I decided to swap out most of the dual-in-line chips with known good devices from my other cards, simply because it's an easy test to do. But still no luck. The card does seem to be active, and I occasionally get some random garbage on the screen, but otherwise still no joy. So at this point of eliminating possibilities, I then decided to use my W65C02 PLCC to DIP40 adapter to test my PLCC CPU on the existing dual-in-line 6502 CPU card. And it seemed I'd found a problem, as I was still getting random results. So it appeared that my PLCC packaged WDC CPU was not working correctly. Unfortunately, at the time, I only had one of these in stock, so I was then delayed until I could get my hands on another WDC PLCC W65C02. So the next thing I did was to send another order to Mouser for a few more WDC CPU chips to try out. Unfortunately, it takes about a week for a Mouser order to arrive, so unfortunately this project was further delayed. It's now about a week later, and I finally have some additional WDC W65C02 PLCC package chips to try. This is where things got even more interesting, as the new W65C02 CPU chips didn't solve the problem. I was getting the same, apparently random results. It was only then that I took another close look at my PLD logic, and immediately I saw the problem. Despite me noting in my source code comments that I wasn't using memory request because the CreatiVision doesn't use the I/O bank allocation, I had actually created the ROM chip select logic by including memory request, instead of just using the plain clock high signal as I had intended. The result of this is that with my bank select dual-in-line switch in its default off switch positions, the I/O bank signal was activating when the top 256-byte bank of memory was being addressed, effectively deasserting the memory request signal and instead asserting I/O request for this top bank of memory. The top of memory on a 6502 system of course includes the reset vectors. So by me inadvertently using memory request and my ROM chip select logic, the system was failing to read the correct reset vector. And here is my correction. With the PLD source now corrected and the PLD reprogrammed, I can finally do a test again. So let's go. Capture card enabled, and let's apply power. And we finally have success. So my apologies for the delay that this rather stupid PLD code error made to releasing this project video. But hopefully by me sharing this experience, it will perhaps help with any fault finding that you might need to do. At the very least, when you do have a fault, know that you are not alone. It doesn't matter how many years of experience you might have, silly and time-consuming mistakes can still be made. The key thing is to know that locating a fault is always just a matter of patience and time. Fault finding is pretty much just a process of logical testing and logical elimination of each potential issue, and always knowing that you will eventually find the fault. In my case, eventually discovering that I'd made an error in my PLD address to code logic, which, in retrospect, is significantly more likely than a faulty chip. So, now it's over to you to decide what you would like to build with my new favourite 6502 CPU card. Perhaps also time to build your own CreatiVision recreation. So to close out this video, for those interested, I'll just step through the startup screens of the 16 switch to ROM cartridges that I've included in the CreatiVision ROM files. My new video capture card giving you a clean view of the retro graphics of each of these classic CreatiVision cartridges. Have fun. That's it. Thanks for watching.